Hi Neil, welcome to doagtv or doagtv. It's great to have you on the show. Please introduce yourself to our viewers.
Okay, well, I'm Neil Chandler, and I've been working with Oracle for a very long time, over 30 years. And as part of my career working with Oracle, I've spent time running the UK Oracle user group. I also have helped run, founded and run things like the MASH program, which I don't know if our viewers will be interested in at all, which is the MASH program. The UK Oracle user group is the same as DOAG, but for the UK, so exactly the same sort of thing. The MASH program is an idea that came out of originally the UK OUG, but something that we've been talking about for a long time to try and get more speakers involved in speaking at technology conferences, especially Oracle conferences. One of the problems that we face with our conferences is the fact that I have a very male-heavy speaker cohort, and we don't have the greatest of diversity. And more importantly, we don't have too many young people speaking. So the MASH program was designed to try and get young people and diversity into the program and into speaking up on stage. So I do think that on another one of your episodes, you do have other members of the MASH program to talk about it. But please look up the MASH program if you've ever thought of standing in front of an audience and explaining your story. As for me, I've been doing this over 30 years, and I'm basically an independent contractor and consultant who goes from company to company to try and fix their problems. Well, with Oracle at least.
All right, thank you. And now you've introduced yourself. Could you also introduce Exadata to us?
Yeah, so I'm here at DOAG to talk about Exadata and talk about a particular problem that a client of mine faced. But because it's about Exadata, you do kind of need to understand a little bit about what Exadata is and what it does. Now, Exadata has been around for a very long time. I was in a bar in 2009 when it was released, and one of my friends came into the bar and said, I've been running a big query against a huge table with no indexes, and it took 2 seconds. And I said, well, that's just impossible. You can't do that. You can't scan vast amounts of data. He says, I'm on an Exadata. Well, we'd heard about them, but we didn't really know what they could do back then. He was the first person I knew to work on one. And what was interesting about it is that he then explained it. And of course, many of us have then worked on Exadata since. And Exadata does a very, very clever thing. I like to call it Exadata magic. And when you write a query against your database, Exadata can look at that query and say, oh, I don't need to process this in your database. I can take your query and I can process some of it on the storage itself. Now, the storage in Exadata is computers in its own right. And so it will take it and it will actually run on the CPUs on the storage, and it will do all the processing on the storage, or quite a lot of the processing on the storage, some basic where clause, some simple table joins on the storage, and it will then return a much smaller amount of data to the database, which then has far less work to do to return the results to you. It's also got some extra magic involved. So on the storage, it can do some very, very clever elimination of queries. It can say, actually, I've built my own internal indexes. I know what your data looks like, and I know where it is on your storage. So I can take your query and say, I know that this is not in any of this area of the storage, so I don't even need to go and look at it. Whereas traditionally, what a database would have to do is start at the start and start running through all of the storage, taking a very long time, to work out that there was no data there that it needed. Whereas the Exadata can say, I just know it's not there. It can use a storage level index to ignore the storage and just return and do the work on just a little bit of storage that it knows. So that gets returned to your database server, and then it has a tiny bit of work to do to return your results set to you. So Exadata is kind of this magic thing invented by Oracle about 14 years ago.
And they do use indexes.
They do use indexes, yes.
Contrary to some beliefs.
You must use indexes with Exadatas. You may need fewer indexes, and the Exadata puts some of its own indexes on magically against the storage, but you do need indexes, you do need referential integrity, you do need your database to look like a normal database, but you may not need some indexes. But you do need a proper database design for it to work very efficiently. Without the database design and without some indexes, it's still going to be inefficient.
I see. Cool, very cool. Magic.
It is magic. It's very much magic.
If it's so great, why is your talk called Get Me Off Exadata?
Well, it stems from one particular client. And I was at that client doing some quite different work, and they were using some older X7s, and they were end of life. And so the new CTO said to me, well, what can you do to get me off these Exadatas? And I said, well, why do you want to be off the Exadatas? He said, they're expensive. They're very, very expensive. And I said, okay, I can give you some options. I can turn around. We'll get some prices for the new Exadatas, but then we'll do some options to see what else we can do to avoid using Exadatas. And he was like, okay, well, what are my options? He says, well, first of all, you can stop using the application. If you don't want to buy new Exadatas, that's fine. Just stop using the application. He said, but we make a lot of money with this application. So, okay, if you're making a lot of money with the application, perhaps you need something to run it on. And we will need to have a look at the options. So the main three options are, we'll take it off Exadatas and run it on normal Oracle with a storage subsystem. We can look to move it to a different database format, such as Postgres, but that will still require the same level of storage system. And we can look to move it to the cloud. So those are the three main options for you if you don't want to have an Exadata and you don't think it's appropriate to close the application down. We then spent a lot of time, or I should say I spent a lot of time, working out exactly what the Exadata was doing, because you can't go and price up a new storage subsystem to run your database, your 100 terabyte database. You can't price that up without understanding what your requirements are. So a large part of what I was doing was looking at the Exadata and working out just how much magic was going on. So you have to spend time, you look at the database internals, you look on the storage cells, which are doing all of the magic and doing all of the offload processing. And we then could sit and determine exactly how much work is taking place for every, well, as a holistic, an entire system, but also at a very low level, looking at individual bits of code to work out exactly what they're doing and exactly how much ordinary computer processing power you would need to run that. We were looking at one particular SQL, and that one particular SQL was doing 700 terabytes of storage activity per day, which is quite a lot.
Yep.
The system was running at a minimum during core processing hours of 17 gigabytes a second that we could see. You then have to take into account some of the Exadata magic. So we can see it's doing 17 gigabytes a second. That's a lot on a very, very consistent basis. and then you add to that all of the Exadata magic. So we looked at how much was traveling over the network, how much data is going from the storage onto the computers, onto the database. And you discover that it's so much that on a very fast network, it would take an entire day. However, the Exadata wasn't doing any of this transfer of data. It was doing it all on the storage cells. It was offloading 93% of everything the database wanted to do to be worked on by the storage cells. So the storage cells were doing the work that your database server would have done. They're minimizing the data transfer, and which means that you actually need a lot less CPU on your database servers. So instead of your database servers having many, many CPUs, and Oracle licenses are unequivocally expensive. So instead of licensing those, you license your storage. Now, that is still licensable. It's still not cheap, but it is tiny compared to the licensing on a database server. So we worked out all of these storage cells, and we worked out that it was using a good 60 CPUs worth of database just on the storage cells. So if you move away from Exadata, you're going to have to find licenses for an additional 60 CPUs, which is quite a lot if you don't have a ULA, and still expensive if you do have a ULA. And then we were looking at the data transfer, 17 gig a second. The storage cells have also got another one of the Exadata tricks, is its indexing, so it avoids its I/O. So how much I/O was being avoided? Well, Oracle stores and records this as well. And so that 17 gig a second rose to around 20 gigabytes a second. And so we had to take that into account. And so this is the minimum requirement we're going to need from a commodity SAN. We then need to add on to that this was just the base workload, and we had storage peaks. And they were peaking up to 30, 40 gigabytes a second, with some peaks as high as 55, 60 gigabytes a second, which is really big. And so we went out and we then priced some storage to replace the Exadatas. But those storage servers cost more than Exadatas. So it's not really commodity storage. It's big old Exadata, it's the huge storage, hugely capable, quite amazing, insanely expensive. So we also looked at much more commodity level storage by storage vendor Pure. Now Pure do some wonderful storage, but the fastest that they do, their XL170 at the time, will only deliver 20 gigabytes a second. Well, that's the base rate. So, but it is possible to combine them, so you can combine two together and get 35, which means we're actually going to achieve what we need. But then what we also need to take into account is this is the minimum that we need. So the best that they do gives us the minimum that they need. So the problem that we have is that the storage, if we went a traditional route, is going to be more expensive than buying the Exadatas. I suppose we would then say, well, if we can't do it with commodity storage, we're going to struggle to move it to another database platform. So a lot of people look at Postgres, and they think Postgres is the solution to Oracle licensing. And well, for small databases, that may be the case. But Postgres isn't Oracle. It has many things that don't work as well as Oracle. It's a very, very great database solution. But when you're talking databases at scale, you're going to have to rewrite your application to work with Postgres. It isn't Oracle. You've got to look at where Oracle exceeds Postgres in terms of how well it can do things like partitioning for very, very big systems. And you're going to have to look at the storage. Well, the storage is going to be the same as Oracle. So if you're going to move from Oracle to Postgres, you're going to have to put the big storage units in. So it's still going to be more expensive from a hardware perspective, and it may be cheaper from a licensing perspective, but you may not actually be able to run your systems on Postgres, especially if they're very big. I mean, what is a very big database is varied. When I first started in with Oracle 30 years ago, I went to a talk at UK OUG, long before I was involved with UK OUG, and I went to a talk, and an insurance company, very large British insurance company, had a 40 gigabyte database. And we were in shock at how big their database is. All of our databases were a gigabyte. They were tiny. And they had this 40 gigabyte data, and they were adding a gigabyte a month. And that blew our minds. Now, that's just what you get when you install Oracle. 40 gigabytes is the data dictionary. It's nothing. So what's a large database these days? Well, I'd consider a medium database to be a terabyte. If your database is less than a terabyte, it's not large. And large is in the 100 terabyte range. Well, we know Oracle can cope with that, no problem. There aren't many other systems out there that can do OLTP with ACID compliance and all the things you need if you have an important system and you care for your data at that sort of scale. So for this particular customer, moving to Postgres isn't an option, given the scale of their system at the moment. That will change in the future. Maybe.
So, in the end, you didn't succeed. Did I get that right?
Well, they wanted to be off the Exadatas.
Mm-hmm. That was their request, yes.
Yes. When we priced it all up, when we went to, and we checked it all out, and we got some pricing off Oracle as well. It turned out that the Exadatas, despite being a very expensive solution on the face of it, was still the cheapest solution overall. They were, and so as we stand here right now talking, that company is commissioning their brand new X10M Exadatas to run all of their applications on them, which I think is really quite marvellous. It shows the power of Oracle, really.
Well, if it's the best solution for them, it's
absolutely
great.
is, yeah.
And, well, we didn't get to talk about the cloud solution, but
No.
well, obviously in your evaluation, it also turned out that on-premises would have been
for this particular
best.
client, on-prem was the best. We did look at cloud. The only cloud that can do Exadata and guarantee their results is the Oracle Cloud. You've got to run an OCI. Given the amount of throughput they have, you go into someone like Amazon or Azure, that level of throughput in the cloud is really niche. It's really difficult to achieve. You've got to take some really special measures to do that in things like Amazon's cloud. So it's just not suitable. So you could have to run it on OCI, and which is basically the same as running it on-prem, but with Oracle taking care of a little bit of the work for you. Or indeed, if you're using Autonomous, a lot of the work for you.
All right. Well, thank you very much. We've touched upon very few interesting topics. Could have gone on for hours, but that's it for now. Thank you.
Thank you, Sabine.